Now in this lecture we have combined all operations that we have implemented in two-dimensional array to see the time and space complexity of all these operations in a big picture. Now the first operation is we are creating an empty array. Now in case of Java, when we are creating an empty array, it allocates the number of rows and columns in the memory. So that's why when we are creating an empty array, the number of rows and columns that we set are located contiguously in the memory. So that's why the space complexity takes O(n) time complexity. So here m is the number of rows and n is the number of columns. And the time complexity for this operation is O1 because it's not time consuming operation. We are just declaring an array in the memory and all cells are located contiguously in the memory. So that's why it takes O1 time complexity and the space complexity is O(m). Now the second operation is inserting a value in an array. Now when we are inserting a value in the two-dimensional array, we are just setting the value of cell to the given value that we want to insert. So in this case, time complexity will be O1 and space complexity will be O1 because we have already allocated memory for this cell over here when we are creating array. So inserting a new value does not require any extra space over here. We are just updating the value of cell that we have already initialized. So that's why space complexity is O1. Now the next operation is traversing a given array. Now when we are traversing a two-dimensional array, we are visiting all cells of this array over here. So this means that first we are starting from the first row and visiting all cells of the first row, then we are continuing to the second row and then third row until we have finished all these rows over here. So this means that if the number of rows is m and the number of columns in each row is n, so we have to visit all of them. So that's why time complexity will be O(m). Now in this case, space complexity is O1 because when we are visiting elements of array, an extra memory is not required over here. We are just visiting the cell and printing out its value. So it's not space consuming operation. Now the next operation is accessing a given cell in the array. Now whenever we are accessing a given cell in two-dimensional array, in one-dimensional array, the time complexity is O1 because we know the physical location of these cells over here. That's why it's not taking much time to find this element. We are just referring the physical location of this cell over here and accessing the value. So that's why time complexity and space complexity is O1. Now the next operation is searching a given value in the array. Now as we mentioned, there are many searching algorithms for searching two-dimensional array, but in this case we have explained only linear search. So this means that in the worst case, if the element does not exist in the two-dimensional array, we have to visit all elements of two-dimensional array. And we have already mentioned that when we are visiting all elements of two-dimensional array, it means that we are traversing all elements of two-dimensional array, and this takes O(m) time complexity, where m is the number of rows and n is the number of columns. Now the space complexity for this operation is O1 because an extra space is not required over here as well. Now the last operation is deleting a given value. Now similarly, when we are inserting a value in two-dimensional array, we are just updating the value of current cell. And here also, we are just updating the value of given cell. So if the default value is 0 or -1 or -2 to the power of 31, we are just setting this cell's value to this default value that we have set before. So that's why space and time complexity will be O1. So while doing this operation, an extra memory is not required and an extra time is not required to perform this operation over here. So with this we have come to the end of this lecture. So in this lecture I put all operations that we have performed on two-dimensional array together to see the big picture of time and space complexity of two-dimensional array. So hopefully everything is clear about these operations and time and space complexity of these operations over here. So see you in the next lecture.